All right, so following up our lecture on rectangular components, this is a quick example to show you how you would apply those concepts to what appears to be some kind of post, telephone pole, something with three different forces on it. Two of these forces, the 500 Newton and the 200 Newton, are applied. We're not given the angle, but we're given a ratio of x, y, and a hypotenuse, a triangular ratio, which we can use to find the components. And the 365 are given as 41 degrees from the vertical. So let's go ahead and take a look how we would do this. Last time we said that we can say that our resultant force in the x direction is equal to the sum of all of the component forces in the x direction. So one by one, let's start with the 500 Newton. Its component in the x direction would be 24/25 plus this 200 Newton. Its component in the x direction is 4/5 minus this 365 newtons because it is in the negative direction. And in this case, it would be the sine of 41 degrees. And if I punch all this into my calculator, what I end up with is my resultant in the x is 400.54 newtons. Same idea in the y direction. Sum of the forces in the y direction. So over 500 Newton force, the y direction component is that 7/25. The 200 is pointing down, so I have a negative 200 newtons. In the y direction, that would be 3/5. And the 365 is also pointing down, so I have minus 365. That is the cosine of 41. And if I sum all that together, I end up with negative 255.47-ish newtons. So if I'm looking for my total resultant from those three forces, what I've just found are my two components. So like we talked about before, solving these things backwards, going back to my coordinate system, I have this in the x direction. I have, what was it, 400.54 newtons, and in the y, so I'm adding these head to tail, in the y, 255.47 newtons. So my resultant vector, I'll draw it in blue so it stands out a little bit. Is the following. So I use a little Pythagorean theorem. And that gives me a value of 475.07 newtons. And then to get the associated angle inside here, going back to my trig functions, I know I can take the inverse tangent of the opposite, 255.47 over 400.54. And that gives me 32.53 degrees. So as a final answer, I would probably say that my resultant vector is equal to 475.07 newtons at an angle of 32.53 degrees. And so we know what I'm talking about. That is down from the positive x-axis. So that's a basic example. You could also more formally draw some kind of table and break them into components that way, but in essence it's just adding all of your x's together, adding all of your y components together, and then using Pythagorean theorem to find the overall resultant, and you're off. So I hope that was a little enlightening, and I look forward to talking to you soon. Thanks.